and a very warm morning to Ms. Gunn. Today we are here gathered to demonstrate advanced function. The unit that we are undertaking is Unit 3. What is Unit 3? Unit 3 comes under rational function. At first, before we begin, we would like to introduce ourselves and the group. The group members are as follows. Myself, Rayan, Sam Wen Hui, and number 3rd, Jian. To further demonstrate, here are the follows. Advanced function, general introduction to the unit, and our unit, Unit 3, rational function. So before we start our unit, we need some prerequisite skills. So as far as we know now, what is polynomial? So the question is, what is rational function? We can say it as follows. The division of a polynomial function is a rational function. The second prerequisite will be factorized polynomial. So here is an equation. X squared plus 7x plus 12. So now we have to look at the number over here, 12. So what can we do? 12. Which number is divisible? So we can think 12 can be divided by 3 and 4. 3 and 4 adds up to 7. So we can say x plus 3 whole bracket x plus 4. We can write this polynomial over here in a factorized form like this. Now we're going to talk about rational function. Rational function takes the form of, let me write it over here, f of x is equal to p of x divided by q of x. We already know that p of x and q of x are two different polynomials, but there's a restriction towards this function. Q of x can never be equal to 0. As we know in the mathematical form, anything divided by 0 is undefined. So there's a restriction towards this. And by plotting this, the graph will at least have one discontinuity, since the denominator cannot be equal to 0. Now let's look at the function f of x is equal to 1 divided by x. So looking at this function, we are going to replace the x values with the values over here. So taking a calculator, if we replace x value as minus 2, we get an answer of minus 1 by 2. By substituting minus 1 into the equation, we get the value of minus 1. Now let's see what happens if we put in 0. Oops, an error. Undefined. If we put 1, positive 1 comes to 2, and if we put 2, it comes to positive 1 by 2. So over here, error. Why? Let me demonstrate this by going into decimals and plotting the function. Our function was f of x is equal to 1 divided by x. We can put y is equal to 1 divided by x. So let's see this function. For each and every x value there is a y value, but there is no interception in x, 0. So what can we say about this? The graph never touches the 0 line. So further in the topic, we're going to learn about domain, range, and asymptotes. And again, we will see at intercepts. And finally, the rate of change. Now, we're going to look at a function. Let's say our function is f of x is equal to 1 divided by 3x minus 1. To find the domain. So since we know that division by 0 is undefined, therefore we'll get a restriction. Let's find the restriction. 3x minus 1 cannot be 0. So x cannot be 1 by 3. So what can we write about the domain? Domain can be x will be all rational values, but x cannot be 1 by 3. Bracket closed. Now we are going to plot this graph. By going into Desmos, we can say that y is equal to 1 divided by 3x minus 1. So minus 1 gives us a interception in minus 1. So now let's look at the graph. By looking at the graph, as we approach x from the negative, the values of fx increases more negative, more and more negative. And as we approach from the right, the value of fx increases positively. And the imaginary line that goes from here is the asymptote. Where is our asymptote? Our asymptote is in positive 1 over 3. Now we are going to see how a function has x-intercept and y-intercept. For example, let's give you a function of h of x is equal to 3 divided by x plus 2. To determine the x-intercept, let h of x equal to 0. Since x has no value, therefore we can say that there is no x-intercept. For the same function, let's go for y-intercept now. For y-intercept, we have to put h is equal to 0. That is x value. So h of 0 is equal to the function over here. That is 3. X instead of x will have 0, substituting 0 into the equation, plus 2. So we can see 3 by 2. So this 3 by 2 is your y-intercept. To demonstrate this, now we're going to go into Desmos. Plotting the equation over here, y is equal to 3 divided by x plus 2. X plus 2. So there is no x-intercept, as we can see over here. Let me zoom out. We have a y-intercept, 0, 1. Now we're going to demonstrate the rate of change. In order to get the rate of change, we need a function. Let's say our function is g of x is equal to negative 1 over 3x plus 2. So in order to find value of x, we have to let the denominator equal to 0. So we get 3x plus 2 is equal to 0, or the value of x would be negative 2 over 3, which gives a value of negative 0.66. Now we're going to plot this in decimals. So now we'll take two values left of negative 0.66. Let's take a look at the point of negative 8 and negative 7. For negative 8, 0.045, and negative 7, 0.053. The value will be recorded. Coming back, the values that we achieved was at x equal to negative 8, f of x equal to 0.045. Again, at x equal to negative 7, f of x is equal to 0.053. So we know that to find slope, there is a formula. The formula is as follows: y2 minus y1 divided by x2 minus x1. The values over here, we're going to substitute these values into this equation so that we get y2, this one. So we write 0.053 minus 0.045. Divided by x2 minus x1. x2 is negative 7, x1 negative 8. So we can write negative 7 in a bracket minus negative 8. And the value that you get is your slope. So coming to the end of the unit, the key concepts. The reciprocal of a linear function has the form of f of x equal to 1 divided by k x minus c, where k is constant. The restriction on the domain of a reciprocal linear function can be determined by finding the value of x that makes the denominator equal to 0, x equal to c by k. I further demonstrated on my earlier examples where x value is taken out. The same with the vertical asymptote. Now come in the graph. I have even demonstrated an example where the value increases negatively for this graph and the value increases positively over the y-axis in this graph, where k is more than 0, and on the other hand, where k is less than 0. And using reciprocal of a linear function or any function, linear or quadratic, we can demonstrate a real-life example, as in there is a lot of pollution going on in our city, in our country. We can track the pollution and even track how many days or how much amount of money that is required in order to clean it. Thank you for bearing with me, and further on to demonstrate our Unit 3 will be taken out by my colleagues. Thank you, Ms. Jian.
Now let's talk about 3.2 reciprocal of a quadratic function. This is the rational function. What is rational functions? Rational function is the fraction of polynomial functions. Rational functions has different degrees like 0, 1, 2. Rational functions. What is the formula of rational functions? The formula of rational function is px over qx. Rational function has discontinuous with asymptotes. You can see from the screen, the examples are given. From the graph, the two lines are not connected with each other. Restriction. The restriction of a function f is a new function f, obtained by choosing a smaller domain A for the original function. The notation is also used. This is the example given for the restriction. Reciprocal of a quadratic function. Consider the functions fx equal to 2 over x squared minus 9. Find the domain and the asymptotes. Determine the intercepts, graph the function, and state the range of the function. This is another question. Determine the intervals where fx equal to 3 over 4x squared plus 5x minus 6 is increasing and where it is decreasing. The method is given. So the answer is left of the slope is positive and increasing, right is negative and increasing. Another example 2. Determine the key features of the function fx equal to 10 over x squared plus 9 and sketch the graph. Graph is given on the right side. Method is given on the left side. 3.3 Rational functions of the form fx equal to ax plus b over cx plus d. So what is fx equal to ax plus b over cx plus d? Fx equal to ax plus b over cx plus d. X and y are the coordinates of point on the graph. The asymptotes of the function are x equal to minus d over c and y equal to a over c. A, b, c, and d are all constants. Two examples are given. So, this is another question. An equation is given fx equal to 4x plus 8 over 2x plus 4. Find a, b, c, and d. The answer is a equal to 4, b equal to 8, c is 2, and d is 4. It's time to determine key features. Example, fx equal to 4x over x minus 2. Find the vertical asymptotes. Find the horizontal asymptotes. Find the x-intercept. Find the y-intercept. Find the slope. Find the intervals. And find the end behavior. This is the answer. You can see the answer for vertical asymptotes is 2, horizontal asymptote is 4, y-intercept is minus 2, x-intercept is 0, the negative slope is decreasing, and the positive slope is increasing from 0 to 2. The intervals is 0 and infinity and minus negative infinity and 0. The end behavior is from high to low or low to high. So, do you understand?
all solve rational equation and inequalities. First at all, the guideline for solving the rational equation are given. Factor all of the denominators. Then multiply each side of the equation by the least common denominator. It means LCD. Next, solve the resulting equation. After that, check your solutions in the original equation. You must exclude the value that makes the denominators of a rational expression equal to 0. Let's have an example. X minus 5 over x squared minus 2x minus 8 equal to 5x minus 1 over x squared minus 4. Solve this question. Next question. 2 over 3 minus 5 over 6 equal 1 over t. Let's do another question. X plus 2 over x minus 6 equal to x minus 1 over x plus 2. 3.5. Modeling with rational function and equation. Making connection with rational function and equation. Example 1. The intensity of sound varies inversely with the square of the distance from the source. A sound has an intensity of 25 dB at a distance of 30 m. A. Determine an equation to relate distance and intensity. I equal to K over D square. K equal to I over I times D square. K equal to 25 times 30 square. K equal to 22,500. Equation I equal to 22,500 over D square. B. What would be the second intensity if the distance is 15 meters? I equal to 22,500 over D square. I equal to 22,500 over 15 square. I equal to 100. The sound intensity increased to 100 dB.